Hello and hello everybody tuning in with me today. Hope you all are having a good Saturday, and of course, welcome to the stream everyone. Before we begin, I would like to remind everyone to spread the stream around like wildfire and let everyone know that the stream is in effect and in the house. And if you haven't already done so, please click the share buttons to spread the stream around like wildfire. It's just a frickin' click. And oh yeah, don't forget to over on the Twitter and the Mastodon, make sure you like or repost my most recent tweet on Twitter, or favorite or boost or whatever my most recent post on Mastodon, and share the stream with your friends throughout the world. Alright folks, welcome everybody, thank you for tuning in with me. We are now at day 16 of the Advent of Cyber 2023. Day 16, for those of you who are keeping track. We're gonna be doing more, I'm assuming, machine learning, because I've had a look at the I've had a little bit of a look at the TryHackMe room task we're gonna be doing tonight. Now, before I forget, I would like to let everyone know, please stay tuned, because I don't know what time Advent of Cyber will be tomorrow, whether it's gonna be at nighttime or in the daytime. It all just depends. And shut my phone up. It all just depends on plans I have. Hopefully, it means just going out and doing some Christmas partying and stuff, holiday partying. At least that will put me in the damn Christmas spirit. Which, not gonna lie, I've been lacking it. I've been lacking the Christmas spirits for a while now. So, hopefully this will mean a better Christmas spirit for me. Anyway, folks, trying to think what we're going to talk about tonight. Oh yeah, we're talking about Advent of Cyber. So, I also gotta poke one of my friends here in a bit. See if I'm gonna poke one of my friends at some point soon. See if we're gonna be able to. We'll see what happens. Anyway, so I don't know what time Advent of Cyber will be tomorrow. It's all gonna be plan dependent, basically. Anyway, let's go ahead and get ready to do some Advent of Cyber stuff. I'm just gonna log into my hack top over here. I got a hack top. And, of course, we cannot hack without the monster, so. Give me my monster. Give me the monster. Alright, where's my monster at? Where's my monster? Alright, here. We're not gonna start without a can of monster. That's what we do, man. And before we begin, I want to remind everybody, we will not be streaming on YouTube any longer tonight than usual. We're gonna, after the Advent of Cyber stream, I'm gonna turn off the YouTube stream for the rest of the night, because we're going Twitch only for Secret Karaoke. And all of you guys can just tune in to Secret Karaoke in the Twitch link in the description below. That's twitch.tv/Kiri Bloodrose. All one word, no underscore. Kiri Bloodrose on twitch.tv. Anyway, folks, let's go ahead and get started with the Advent of Cyber stuff. And we'll have a bit of fun doing it. And where's my frickin' HDMI cord? That's the one thing I forgot to do, is plug in HDMI cord to the HackPop. There it is. So let me plug this shit up in here. There we go. Now we're talking. Alright, let's go ahead and get started with Advent of Cyber. Day 16, for those of you who are keeping track. Day 16 of Advent of Cyber. Alright, folks, let me make sure I don't leak anything I shouldn't be leaking. I did a little bit of working on stuff this afternoon, so, and I'm behind an NDA, so I don't want to. Yeah, I'm behind I'm under an NDA myself, so I don't want to leak what I'm not supposed to, you know, that kind of stuff. Anyway, folks, let's go ahead, get clicked on over the Advent of Cyber, and let's start hacking. And of course, I am going to be in the, let me pop into the Hackers Hackin' chat room over here. Hackers Hackin'. Let's get started. Alright, folks, let me go ahead and click the Start Machine button over here. And add an hour. So let's continue on with the story. McReady has locked McSkitty out of his Elf HQ. Admin panel by changing the password. To make it harder on McSkitty to perform a hackback, McReady has altered the admin panel login so that it uses a CAPTCHA to prevent automated attacks. A CAPTCHA is a small test, like providing the numbers in an image that needs to be performed in order to ensure that you are a human. This means McSkitty can't perform a brute force attack. Or does it? After the great success of using machine learning to detect defective toys and phishing emails, McSkitty is looking to you to build him a custom brute force script that will make use of machine learning to solve the CAPTCHA and continue with the brute force attack. There is, however, a bit of irony in having a machine solve a challenge specifically designed to tell humans apart from computers. So the learning objectives today will be complex neural network structures, how does a convolutional neural networks function, using neural networks for optimal optical character recognition, and integrating neural networks into red team tooling. Before moving forward, let's review the questions in the connection card. Do we need to start the attack box? No. Do we start the VM? Yes, we did. Is there a split screen available? Yes, there is. Direct link? Nope. Credentials? Nope. So let's go ahead and open the split screen before we get started. We're gonna split it into another tab. And we're gonna get started. So remember, start the machine and open it in split view mode if you need a refresher. It's just like the past couple of tasks that we've done the past couple of nights. In today's task, we're gonna get our first look at how red teams can use machine learning to help them attack systems. But before we can start attacking the admin portal, we'll need to expand on some of the machine learning concepts taught in the previous tasks. Let's dive in. In the previous tasks, we talked about neural network structures. However, most of these structures were fairly basic in nature. Today, we will cover an interesting structure called a convolutional neural network, or CNN, just like the news network. But we're not talking about the news network. We're talking about CNNs, okay? Okay, remember that. CNNs are incredible machine learning structures that have the ability to extract features that can be used to train a neural network. In the previous task, we used the garbage in, garbage out principle to explain the importance of our inputs having good features. This ensures that the output from the neural network is accurate. But what if we could actually have the neural network select the important features itself? This is where CNN comes in play. In essence, CNNs are normal neural networks that simply have the feature extraction process of the network itself. This time we're not just using maths, but we're combining it with linear algebra. Again, we won't dive too deep into the maths here to keep things simple. We can divide our CNN into three main components: feature extraction, fully connected layers, and classification. We've already covered the last two components in previous tasks as a simple neural network structure, so our focus today will be on the feature extraction component. CNNs are often used to classify images. While we can use them with almost any data type, images are the simplest for explaining how a CNN works. This is the CAPTCHA we are trying to crack. Since we'll be using a CNN to crack CAPTCHAs, let's use a single letter in the CAPTCHA as our image, or number, which is 4. The first question to answer is, how does the CNN actually perceive this image? The simplest way for a computer to perceive an image is a 2D array of pixels. A pixel is the smallest area that can be measured in an image. Together, these pixels are what create the image. A pixel's value describes the color that you are seeing. There are two popular formats for pixel values. RGB, the pixel is represented by 3 numbers from 0 to 255. These 3 numbers describe the intensity of red, blue, and green colors, or RGB colors, of the pixel. And grayscale is the pixel. The pixel is represented by a number from 0 to 255. 0 means the pixel is fully black, and 255 means the pixel is fully white. Any value in between is a shade of gray. So essentially there's like 200 and technically 254 shades of gray instead of just 50, which is interesting. To represent the image as a 2D array, we start at the top and capture the value of each pixel, working our way to the right in rows before moving down. Let's take a look at what this would look like for our CAPTCHA. If you follow along, we now have a representation of the image. Let's take a look at what the CNN will do with the image. How's it going? There are 2 steps in the CNN feature extraction process that are performed as many times as needed. The first is convolution. The maths is about to get slightly hectic here, so let's take a deeper breath and dive in. During the convolution step of the CNN extraction feature, we want to reduce the size of the input. Images often have several thousand pixels, and while we can train a neural network to consider all of these pixels, it will be incredibly slow without really adding any additional accuracy. Therefore, we perform convolution to summarize the image. To do that, we moved a kernel matrix across the entire image. Calculating the summary, the kernel matrix is a smaller 2D array that tells us where in the image we are currently creating our summary. This kernel slides across the height and width of the image to create a summary image. Let's take a look at the animation below. Right here. We have some hexadecimals. In this matrix. So as you can see, we start at the top left of our image looking at a smaller 3x3 section. We then calculate the summary by multiplying each pixel with the value in the kernel. These kernel values can be set differently for different feature extractions, and we're not limited to a single run. The values of these pixels are usually randomized at the start and then updated as the network is busy training. We can say that each kernel run will create a summary slice. As you can see from the animation, by sliding the kernel across the image, we create a smaller summarized slice of our image. There are a couple of reasons why we want to do this. As mentioned before, we can create a neural network that takes each pixel as input. but this would be an incredibly large network without improved accuracy. The summary created by the convolution process still allows us to capture the image's important details without needing all the pixels. If our CNN's accuracy decreases, then we can simply make the kernel smaller to capture more details during the input phase. The term used for this process is sparse interaction, as the final neural network won't directly interact with each pixel, basically. So, if you would like to learn more, we've got some articles right here. Concepts of dense and sparse in the context of neural networks in here. We'll be able to link it to you guys, because I'm on a different I mean, I could link it. I'd just have to pop over to the link. I'd have to pop over to TryHackMe on my primary laptop, which I'm streaming from. Just link it to the chat. I hope to God my chat understands the shit. Anyway, if we calculate, hang on a second, let me the link and copy it over. If we calculate a feature in one location in our image, then that feature should be just as useful as a feature calculated in another location of the image. Making use of the same kernel to determine the summary slice means this condition is met. If we update the weights in one of our kernels, it will alter the summary for all pixels. This results in something called the property of equivariance to translation. Simply put, if we change the input in a specific way, the output will also get changed in the same way. And here's another link if anyone wants to learn more about it. If we perform the summary creation with several kernels to create several slices that are then sent to the next step of our CNN feature extraction process. And I'm doing okay, I guess. It's just been a meh week. So pooling, the second step performed in the CNN feature extraction process, is pooling. Similar to convolution, the pooling step aims to further summarize the data using a statistical method. Let's take a look at our single slice and how a max pooling will provide a summary of the maximum values. So let's have a look at this animation here. Single step slice, max pool with 2x2 filters and stripe 2. I will look at it again. So as you see, for each kernel, we create a summary based on this statistical method. For max pooling, this is finding the maximum value in the pixels. We could also use a different statistical method, such as average pooling. This calculates the average value of the pixels. And that's it. Basically it. That's how the CNN determines its own features. Depending on the network structure, this process of convolution and pooling can be repeated multiple times. In the end, we're left with the pool of values of each of our slices. These values now become the inputs for our neural network. Now that we have our features, the next stage is really very similar to the basic neural network structure we used back in the introduction to machine learning task. We'll create a simple neural network that takes inputs, the summary slices from our last pooling layer, run them from the hidden layers, and then finally provide an output. This is called the fully connected layers portion of the CNN, as this is the part of the neural network where each node is reconnected to all the other nodes in the network layer. Lastly, we need to talk about the classification portion of the CNN. This is the output layer from the fully connected layers portion. In the previous tasks, our neural networks only had one output to determine whether or not a toy was defective or whether or not an email was a phishing email. However, to crack CAPTCHAs, a simple binary output won't do. We need to tell the network to tell us what the character and later the sequence of characters is. Therefore, we'll need an output node for each potential character. Our CAPTCHA example only contains numbers, not letters, so we need an output node for 0 to 9, totaling 10 output nodes. Having multiple output nodes creates a new interesting feature for our neural network. Instead of getting one answer now, all 26 outputs will have a decimal value between 0 and 1. We'll then summarize this by taking the highest value as the answer from the network. However, nothing is stopping us from reviewing the top 5 answers. For instance, this can help us identify areas where our neural network might be having issues. For example, there could be a little confusion between the characters of M and N, as they look fairly similar. Reviewing the output from the top 5 nodes will show us that this might be a problem. While we may not be able to solve this confusion directly, we can actually use this to our advantage and increase our brute force accuracy. We can do this by simply discarding the CAPTCHA if it has an M or an N and requesting another to avoid the problem entirely. Now that we've covered the basics, let's take a look at what will be required to train and use our own CNN to crack the CAPTCHAs. Note that the following steps have already been performed for you. The next steps will be to perform the will be to perform in the hosting the model section. However, understanding how training works is an important aspect, so please follow along and attempt the commands given. We'll be making use of the attention OCR for our CNN model. This CNN structure has a lot more going on, such as LSTMs and sliding windows. But we won't dive deeper into these steps in this instance. The only thing to note is that we have a sliding window, which allows us to read one character at a time instead of having to solve the entire CAPTCHA in one go. We'll be making use of the same steps followed to create CAPTCHA 22, which is a Python pips package that could be used to host a CAPTCHA cracking server. If you're interested in understanding how this works, you can have a read here. While you can try to run all of this software by yourself, most of the machine learning component runs on a very specific version of TensorFlow. Therefore, making use of the VM attached to the task is recommended. In order to crack the CAPTCHA, we'll have to go through the following steps. Gather the CAPTCHAs so we can create labeled data, label the CAPTCHAs to use in a supervised learning model, train our CAPTCHA cracking CNN, verify our CAPTCHA cracking CNN, export and host the trained model so we can feed it CAPTCHAs to solve, and create and execute a brute force script that will receive the CAPTCHA, pass it on to be solved, and then run the brute force attack. Steps 1 through 4 are quite taxing, so they have been completed for you. We'll do a quick, so we're not going to do them because they've already been done for us, but we'll read it over. But we'll do a recap of these steps, what these steps involve, before moving on to hosting the model and cracking some CAPTCHAs. To do this, you'll have to start the container, the Docker container. In a terminal window, execute this command right here, which I'm going to highlight right here, to the Docker run command. I'm even learning Docker, but I'm getting better at it. Something I really need to do is learn Docker more, as it's very important. This will start a Docker container that has a TensorFlow and OCR already installed for you. You will need to connect to this container for the next few steps. First, you will need to find the container's ID with the following command: docker.ps. Docker ps. Yeah, space, not a dot. Take note. So we can do that actually. It's not very taxing. Docker ps. Oh. Okay, let's start the Docker container then. Docker run. Tech B. Okay, so we may have to do these commands after all. I misunderstood that part, but now we know. Temp data. And what other commands do we want to type? Temp dir. AOCR full. So we're running the Docker right now. Take note of your containerized ID. That's important. Very important to take note of your container ID. And then we run Docker as exec tech IT Docker exec tech IT. We put in the container. So I gotta stop using control. Oh, here we go. So here's our ID. Bin bash. So we're in the container shell, basically. So we're connected to the container, and we can now navigate to the following directory for the next few steps. cd/ocr. In order to train our CAPTCHA tracking CNN, we first have to create a dataset that can be used for training. So let's take a look at the authentication portal for HQ admin. So let's open up. See if this will open up in the web browser first. Automatically, of course. Yes, it does. Okay. So we've opened the web page in a browser window at the VM, and we've seen the authentication page right here. So as we can see, the authentication portal embeds a capture image. We can get the raw image using a simple curl command from a normal terminal window. So let's go here, curl, and we want hqadmin.thm 8000. Okay, we'll do it in... Can I split? No, I can't split it. Okay. Create a new tab. Perl. Still learning Docker. Still learning Docker. So in the input, the output, we'll see a base 64 encoded version of the capture image. We can write that to write a script that will download the image, and then prompt us to provide the answer for the captcha to store in a training data set. This has already been done for you. You can view the stored data using the following command in the Docker container. So let's run the command ls. Ls. Doesn't matter. This part doesn't matter right here. It doesn't matter if they're out of order or in order, whatever. Raw data and data set. That's a lot of images. That's a lot of images right there. Next, we need to create the training dataset in a format that AOCR can use. This requires us to create a simple text file that lists the path for each CAPTCHA and the correct answer. A script was used to create this text file and can be found under the labeling directory. So we can use this command to view the command for the text file that was created. We want to go into cat, labels, and we want trading.text. Once we have our text file, it has to be converted into a TensorFlow record that can be used for training. This has already been done for you, but you can use the following command to create the dataset. So we want to do AOCR dataset labels training.text and training records. As mentioned before, this has already been done for you and is stored in the labels directory. We have created two datasets, one for training and one for testing. As mentioned before in the introduction to machine learning task in day 14, we need fresh data so that our CNN has never seen before. We need fresh data that our CNN has never seen before to test and verify that the model has been trained accurately, not overtrained. Just as in the previous task, we will only use the training dataset to train the model, and then test the dataset to test its, and then the testing dataset to test its accuracy. Sebo, how's it going? Hi. Drop an alert, nice. Farming evolutions. Very cool, very cool. Hope you're doing well, Sebo. Alright, finally we can start training our model. This has already been done for you, but with all the preparation completed, you would still be able to use this command to start the training. Okay. Apparently there's some issues with the but that's alright. It's already been prepared for us, so hopefully it'll work. So we go CD labels and UCR training dot TF records. Training will now begin. Once training has completed a couple of steps, stop it by pressing the Control and C. Let's take a look at one of the output lines from running the training. Step 1. And step 2. So let's go ahead and stop it. Hang on. Hang on, we need to stop it. In each of these steps, the CNN is trained on all of our inputs. Similar to what was discussed in the introduction to machine learning task, each image is given as an input to the CNN, which will then make a prediction on the numbers that are present in the CAPTCHA. We then provide feedback to the CNN on how accurate its predictions are. This process is performed for each image in our training dataset to complete one step of training. The output from the AOCR shows us how long it took to perform this round of training and provides feedback on the loss and perplexity values. Loss is the CNN's prediction error. The closer the value is to 0, the smaller our prediction error. If you were to start training from scratch, the loss value would be incredibly high for the first couple of rounds until the network is finished. Any loss below 0.005 would show that the network has either completed its learning process or has overtrained on this dataset. Perplexity refers to how certain the CNN is in its prediction. The closer the value is to 1, the more certain the CNN is that its prediction is correct. Consider how perplexed the CNN would be seeing the image for the first time. Seeing something new would be perplexing. But as the network becomes more familiar with the images, it's almost as if you can't show it anything new. Anything below 1.005 would be considered a trained or overtrained CNN. As the CNN has already been trained for you, you can now test the CNN by running AOC testing.tf records. So let's run test and testing TF records. The training will now begin. Once a couple of steps are complete, you can stop it by using Control C. Come on. Here we go. Let's take a look at two of the lines. As you can see from the testing time, running a single image sample through the CNN is significantly faster than training it on an entire dataset. This is one of the true advantages of neural networks. Once training has been completed, the network is usually quick to provide a prediction. As we can see from the predictions provided at the end of the lines, one of the CAPTCHA predictions was completely correct, whereas another was a prediction error, mistaking a 5 for a 6. If you compare the loss and perplexity values of the two samples, you will see that the CNN is uncertain about its answers. We can actually use this to our advantage when performing live predictions. We can create a discrepancy. I can't speak today. So we can create a discrepancy between CAPTCHA prediction accuracy and CAPTCHA submission accuracy by not submitting the CAPTCHAs that we are certain about. Instead, we can request a new CAPTCHA. This enables us to change the OPSEC of our attack. We can even take this a step further and save the CAPTCHA images that were incorrect on submission. We can then label them manually and retrain our CNN to improve on its accuracy. This way we can create a super CAPTCHA cracking engine, which we can read about the process in here. We could even take this a step further and save the CAPTCHA images that were incorrect on submission. We can then label these manually and retrain our CNN to improve on its accuracy. Oh, we've already read through that part. Okay. Now that we have trained our CNN, we'll need to host the CNN model and send it CAPTCHAs through our brute force script. This will use TensorFlow serving. Once a CNN has been trained, we can export the weights of the different nodes. This allows us to recreate the trained models, the trained network at any time. An export of the trained CNN has already been created for you under the /OCR/model directory. We'll now export that model from the Docker container using the following command: cd/OCR, and then we'll do it like this: cd/OCR, and do this. Copy R model. Hang on. Model and temp dir. Once that's complete, you can exit the Docker container terminal by using the exit command and kill it using this command: docker kill container ID. Exit, stage right, Docker, yes. Go ahead and copy the container again. Copy that. And we want to run docker kill. And the container ID. TensorFlow serving will run in a Docker container. The container will then expose an API that we can use to interface with the hosted model to send it a CAPTCHA for prediction. You can start the serving container by using the following command: docker run tact tac rm tacp ports. We want 8501, 8501, then TACV, temp, data model, exported model. And then models. Model name OCR tensor flow / serving. So let's run the command right now. And this will start a new hosting of the OCR model that was exported from the AOCR training Docker container. We can connect to the model through the API hosted on localhost port 8501/v1/models/OCR. Let's do that. So is it HTTP? Yes. Not HTTP. Hang on. Do I have? I do. That's interesting right there. But it's double check. The 501. V1. And let's go to model/OCR. Interesting. So we're finally ready to help Kiri regain access to the HQ admin portal. So we're now ready for the brute force attack. We've been provided a custom script that we will use. We can find the custom script and password list in the desktop in the brute forcer folder. Let's take a look at the script. Which we can see it is written in Python. So a little bit of a looky-loo at the Python script. So let's dive into what it is doing. First, we load the libraries that will be used. We'll mainly make use of Python's request library to make the web requests on our behalf. Next, we'll load our password list, which will be used for the brute force attacks. In a loop, we will perform our brute force attack, which consists of the following steps. 1. Make a request to the HQ admin portal to get the cookie values and capture image. Next, submit the capture image to our hosted CNN model. Determine if the prediction accuracy of the CNN model was high enough to submit the captcha attempt. Submit a brute force request to the HQ admin portal with the username, password, and captcha attempt. Read the response from the HQ admin portal to determine what to do next. Let's run our brute force attack using the following command in a terminal window. So let's look for it here. Don't like this dock here. Okay, CD desktop. Hold on. CD desktop. we can see Brute Forcer, LS. Run this in Python 3. We got it. We're in. So now we enter the username and the password that we've just obtained. Nice. We'll copy the password. Hang on. Copy, paste it. And then we enter the CAPTCHA. Hell yeah. And we have a flag. In conclusion, we have shown how machine learning can be used for red teaming purposes. We have also demonstrated how we can create custom scripts to perform tasks such as brute forcing the authentication of a web application. All we need is a spark of creativity. While we could have taken a pre-trained model such as Tesseract OCR, it wouldn't have been nearly as accurate as one trained specifically for the task at hand. This is true for most machine learning applications. While generic models will work to some degree, it's often better to train a new model for the specific task we're tackling. Now that you've seen a taste of what is possible, the sky's the limit. And we'll go ahead and start wrapping things up. Let's get some answers, input. Also, if you enjoyed this room, check out the red teaming learning path. It's awesome. Still working on learning it. Reread through this. Go ahead and I'm not going to terminate it just yet. Let's go through the answers real quick. Well, that's good. At least we're learning something. At least you're learning something. Something OCR. AOCR. Let's be careful. So much overlearning can hurt a simp mind. Now we can terminate the machine. It took us an hour. Again. Okay. I think we're done. We can shut this thing down. Alright. We're pretty much done with Advent of Cyber for tonight. Just finished more machine learning. $5 says that we're gonna see more machine learning rooms. Alright, let me close out the voice chat channel real quick. I'll close that out. Alright, that was fun. Once again, guys, that was Advent of Cyber. We're gonna keep doing this until next Sunday, I think. Is that when Christmas Eve is? Next Sunday? Yeah, I'm pretty sure that is. So, Sunday will probably be the last day of Advent of Cyber. It's sad, but at the same time, a relief, because I don't have to do these every day anymore. At least, they're fine every day when I'm not streaming. Anyway, let's go ahead and we're gonna do some... Before we close out the YouTube side of the stream, we're not gonna be streaming on YouTube much longer tonight because we're doing secret karaoke. Guys, go over to my Twitch chat. Twitch, if anybody's in Twitch, it's not gonna affect you guys. If anybody is watching on YouTube, though, here's the link to my Twitch. You guys can tune in there. Okay. Let's go ahead and get to some shout-outs real quick. We're gonna go ahead and do some chat room shout-outs. And the only people I see in the chat room would be Kami Hatsune7788 and Severuna. Let's see who we got on Twitter. It's the same schmucks. It's the same schmucks, basically simping. I'm not gonna do, I've already shouted you out, where I'm not gonna do any more shoutouts. It's the same simps. Anyways, let's go ahead and get ready for some secret karaoke. Thanks everyone for tuning in with me. I will probably be on, well, I'll see you guys on YouTube tomorrow for the Advent of Cyber Day 17. I don't know what day, or what time that's gonna be though. I'm gonna figure that out tonight. Fucking simps, man. Alright, those of you watching on YouTube, thanks for tuning in. I will see you tomorrow. Go to my Twitch if you want to see some secret karaoke. And those of you on Twitch, I will see you in a bit. I'm going to take a break. Alright. Have a good night, everyone on YouTube.